In this video, we're going to look at solving different types of quadratic equations, and we're going to use different factoring techniques. I'm going to show you several examples in this video, and I'm going to use each of these three techniques at least once. So we've got our guess and check method, we have an AC method for factoring, and a bottoms-up method for factoring. They all work. I'm just going to factor several equations using these different methods so that you guys can see the different ways that will all work. So if an equation is factorable, any of these three methods that I'm going to spell out for you in the next few examples will work. So we are dealing with quadratic equations, and we always want our quadratic equations in standard form before we start. So we have ax squared plus bx plus c is equal to 0. And we'll think about that as being a quadratic, our squared term, our linear term, and our constant terms. The linear term is x to the power of 1. The constant term is x to the power of 0. So in descending order, equal to 0. All right, so let's look at a couple of examples. For our first example, we have x squared minus 7x minus 30 is equal 0. So this is a quadratic equation. We are asked to solve, and it's written in descending order. So I'm going to use the guess and check method here. And the guess and check method is easiest when this leading coefficient is equal to positive 1. Now, guess and check method says, hey, we just look at this C term and we try to come up with some different factors that might add up to give us our middle term here, which is negative 7. So my factors of 30, and this is negative 30, I have negative 30 and positive 1, or 30 and negative 1. I have negative 15 and positive 2, or 15 and negative 2, and then negative 10 and 3, or 10 and negative 3. We can keep going. I have 5 and negative 6, and then negative 5 and 6. Okay, so we would look at all of these factors, and we're going to choose the factor that sums to equal that middle term, negative 7. Of course, we would use negative 10 and positive 3. If I add those together, I'm going to get negative 7. So in this situation, I can write this quadratic equation as x, we'll say x minus 10, and x plus 3. So I have factored the left side of the equation into x minus 10, x plus 3, and it's equal to 0 on the right side of the equation. Now you'll notice I have two factors, two things that are multiplied together, which are equal to 0. At this point, I can use my zero product principle. And what the zero product principle says is that if I have two factors equal to 0, I can take each of those factors and set them equal to 0. So I have x minus 10 equals 0, or x plus 3 is equal to 0. And solving this, I will get x equals positive 10, or the other one, I would get negative 3. So I have two unique real number solutions, two different real number solutions for this quadratic equation. And the last step whenever you're solving any equation is always to check. So if I plug in 10, that's 100, minus 70 minus 30 equals 0, which checks. Plugging in negative 3, I would get 9 plus 21 minus 30 equals 0. So both of those check. So again, we use the guess and check method to factor, and we said that's much easier when we are dealing with a leading coefficient of positive 1. So now let's look at the guess and check method when we have a leading coefficient which is not equal to positive 1. In this next example, example B, we're going to solve 2x squared minus x minus 15 is equal to 0. So you'll notice here my leading coefficient is not positive 1, it is 2, which means we have an extra factor to think about when we're dealing with guess and check. So let's look at our factors for the first term. Here we had 2x and x. Just separate each x and then come up with two factors. So in this case, we have 2x and 1x. And then we'll look at factors for 15. So 15, and this is negative 15. I could have negative 15 and 1 or positive 15 and negative 1. Same with 5 and negative 3 or negative 5 and positive 3. And so this is where it can get a little messy because essentially we're just going to create two pairs of factors. I'll go ahead and put my 2x and my x, and I've got to kind of guess and choose which pair of factors for my constant term are going to give me an inner and an outer product that will sum to equal -1, right? We have -1 here in the middle. So I'm going to lean away from 15 and 1 because those aren't very close together. I think 5 and 3 give me a better shot. So what I might do is I come over here and go, well, here's -5 and there's positive 3. So we'll look at that. That gives me 3x, and here that gives me -10x. And I ask you, if I add these two numbers together, will they give me -1? And the answer is no. So now I might look at reversing this positive 3 and -5, either switching them or just switching the signs. Now, if I just switch the signs, that would give me a -3 and a positive 10. So I'm going to look at switching both of the terms. So I'm going to try -5 and positive 3. Again, we'll look at our outer and inner factors. My outer, 2 times 3, that gives me 6x, and my inner is -5x. And those do add up to equal a value of 1, but they sum to equal +1. And we are looking for -1 here. So what we actually need to do is we'll switch just those two signs, the plus and the minus. So if I switch my plus and my minus, I'll get a -3 and a +5. You'll notice that gives me +5x, -6x, and those two terms do indeed sum together to give me that -1 value. So what we are looking at here is my factored form, and then by the zero product principle, I'll say 2x plus 5 equals 0, or x minus 3 equals 0. And that will give me that x equals -5/2, or the other factor would give me +3. So you can see we have two solutions here. So the guess and check, again, when we have a leading coefficient that's not +1, it can become a little bit hairier. All right, so now let's look at the AC method. And the AC method is a method that works when we have this leading coefficient that's not +1. For our third example, we're going to solve the quadratic equation 2x squared minus 15x minus 27 is equal to 0. I'm going to use what's called the AC method here. So keeping in mind that my terms are organized in descending order. I have A, B, and C. When we have a leading coefficient that's not 1 and we want to try and factor, we look at A and C. Here my A value is 2 and my C value is -27. What we do with those two values is I'm going to multiply A times C. And A times C, 2 times -27 is -54. All right, so again, we look at listing factors, and 54 has quite a few factors. What I've done is I've listed all of those factors out here. And our goal is we want to look at all these different pairs of factors, again, making sure we're considering the signs. This is negative, so one needs to be positive and one needs to be negative. We want to choose a pair of factors that's going to sum to give us negative 15. I picked negative 18 and 3. If I add those two numbers together, that's going to give me negative 18. So by the AC method, we essentially unadd that term in the middle. So I'm going to write negative 18x plus 3x minus 27 equals 0. Now, negative 18 plus 3, those add together to give me negative 15. So I like to say I unadded them. One question I always get here is, does the order matter? And no, the order does not matter. You could have said positive 3x minus 18 or plus 3x minus 18. You'll get the same answer either way. So the order doesn't matter at all. So once we have it written like this, now we look at each of my two pairs. And what we're going to do is we're going to use factoring by grouping. So my first two terms, I'm going to factor out a GCF. I'm going to factor out 2x. When I factor out 2x, that leaves me with x minus 9. And for my second two terms, I'm going to factor out a positive 3. You'll notice when I factor that out, that also leaves me with x minus 9. So these two factors have to be exactly the same. And you must factor a GCF out for each pair. If this is any number other than a positive 1 in the front of each of these pairs, you must factor a GCF out. So what that gives me here, x minus 9, that's going to be one factor, and my other factor is 2x plus 3. So now I have my two factors equal to 0, and I'll use my zero product principle. So x minus 9 and 2x plus 3, each of those equal to 0. I will get x is positive 9 and negative 3/2. So I have two solutions. I solved this using what is called the AC method. All right. The most confusing step for students is in here, this factoring by grouping step. So you're always just going to split that right down the middle into halves. You're going to factor a GCF out. We get x minus 9. I must factor a GCF out of the second pair. So I get that same binomial x minus 9. It has to be exactly the same. And if this number right here is anything other than positive 1, you must factor something out. So if this was a negative 1, we would need to factor that out to make this work. All right, now let's just look at one more example. I want to show you how to factor using what's called the bottoms up method. For our last example in this video, we'll talk about the bottoms up method. And what the bottoms up method tells us to do is when we're solving a quadratic equation equal to 0, so notice this is in descending order again, we're going to take that a value, if it's anything other than positive 1, I'm just going to bump it over here and multiply the c by that negative 3. So I'm going to rewrite this. X squared plus 11x, that would give me minus 12 is equal to 0. So doing that allows me to factor this rather easily. I have x, that'll be x plus 12, and x minus 1 is equal to 0. So we would be inclined to just jump right in here and say, okay, well, that means negative 12 and positive 1 are going to be our solutions. But we can't just assume that negative 12 and 1 are the solutions because we multiplied this 4 by negative 3. So since I said times negative 3, now I need to divide each of these by negative 3. And that leaves me with x minus 4 and x plus 1/3 is equal to 0. So I multiplied by -3, and then at the end I have to divide by -3. So a lot of students prefer this method. I don't love this method because um, I feel like this step gets forgotten about when we are learning to factor. But I'll show it to you in case you think it works best for you. So solving each of these, I'm going to get x is positive 4 and -1/3. So in this example, I talked you guys through 4 factoring problems. I used a variety of methods. All 3 of those different methods would have worked on each problem. It's just a matter of preference when you're factoring. So you need to find what works for you and learn how to use that properly. And I personally don't care which method you use for factoring as long as you can factor. You'll be able to get by on this specific unit without factoring, but as we move forward and as you advance in math classes, you are required to factor, and factoring needs to be easy for you. The only way to get better at factoring is to practice. I can't emphasize that enough. So if this is something you're struggling with, you really want to buckle down and really work on a bunch of examples. And reach out to me if you need some extra practice problems to work on. All right, well, good luck out there. And again, email me if you have any questions or concerns.